Okay, this is the last machine that we have to cover here. It is on Pulley Systems. In terms of the math, if you thought things have been easy so far, this would be the easiest of the bunch. This just involves counting. If you can count, you can handle pulley systems. There are only two types of pulley systems. There's a fixed pulley and a movable pulley. The fixed pulley stays attached to, well, a fixed point, like, say, the ceiling. So that's this right here. That is a fixed pulley, and you'd string a rope or a string around that pulley. You'd pull with your effort force down. It would move the load force up. That is a fixed pulley. A movable pulley is not attached to a fixed point like the ceiling. It is attached to the load force, like this mass that we're trying to lift right here. And in this case, we're pulling up with an effort force, and the load force also moves up. There are the differences between a fixed and a movable pulley. Of course, if you've seen any pulley systems, you know that you use combinations of fixed and movable pulleys to gain more and more and more mechanical advantage. In this case, we have the effort force pulling down right there, and the load force would be moved up. So the way this works is that the load force is spread out over the strings that are helping you lift the thing up. So the mechanical advantage, at least the ideal mechanical advantage, is simply a matter of counting strings. So you don't have to, if you're taking notes, you don't have to redraw these. These are the first three pulleys that you've already seen. Now, one thing I will tell you is, well, what do we do with this last string, the one that's pulling, the one with the effort force, that one, and that one? So the rule is that if it's pulling upward, then you count it. And if it's pulling downward, then it's not helping you lift up the load and you don't count it. For example, on this very first one on the left, you have just one string pulling up, so it has a mechanical advantage of 1. The effort force is pulling down, so you don't count that last string. However, on the second one, you have 2 strings helping you pull up. So the mechanical advantage is equal to 2. On the third one, you've got 1, 2, 3 strings helping you pull up, but you don't count the last one because it's pulling down and not helping you lift that load, so it has a mechanical advantage of just 3. Some of the questions you're going to have are going to involve drawing these pulley systems. So I'll just tell you that if the string starts from the bottom, you always get an odd mechanical advantage, like here. See, the string started from the bottom. That means down on the movable pulley systems, you're going to get an odd mechanical advantage like the 3. If we were to start it at the top, we would get an even mechanical advantage, for example, 2. And that is how that will work. Now, these next ones want me to draw pulley systems. So I will attempt to do that in this limited space. Normally I do this on the chalkboard where I have lots of space. So to make a mechanical advantage of 5, I'm going to need a series of fixed and movable pulleys. It's only because of experience that I know that I will need about this many pulleys. The main thing here is that I know that I want to get a mechanical advantage of 5, so I have to start it at the bottom. We want an odd mechanical advantage, so I know I have to start at the bottom. That's the rule. This goes up, around, around, around. Let's count them up. We got that one counts because it's pulling up 1, 2, 3, 4, 5. Good. That has a mechanical advantage of 5. Now on my next one, I suspect I'm going to need more pulleys because I think I've maxed out how much I can get out of 2 fixed and 2 movable pulleys. So just to be safe, I'm going to make 3 and 3. I probably only need 2 and 3, but I can never remember which I need. So I'm going to make 3, a big one, a medium one, and a little one. And over here, I'm also going to make 3, a big one, a medium one, and a little one. Admittedly, this is turning out to be a little bit ugly, and that is just because I'm trying to squeeze it into this small space here. So I know that for an even mechanical advantage, I got to start at the top. So I'm going to start right there, and I got to move it around and around using all the pulleys. I'm going to stop right there and see what I've got. I've got 1, 2, 3, 4, 5, 6. Hey, I've done it. I'm all good. I didn't need to use that last fixed pulley. I could have, and I would still get a mechanical advantage of 6, but there I'm done. I'm going to put my arrow and say that's done. I don't like that color though. I'm not going to use that again. So let's switch back to red to start with. For 7, I think I can get away with 3 fixed and 3 movable pulleys. So I'm going to attempt that again. I got a big, a medium, and a little. And then at the bottom, I have a big, a medium, a little. I'm going to go back to my blue. Maybe I'll try green. What the heck? So this time I'm going to start at the bottom. Why? Because I know I want an odd mechanical advantage, and I got to loop round, round, round. I can stop there and count 1, 2, 3, 4, 5. No, got to keep going. How many do I have there? 1, 2, 3, 4, 5. Don't count the last one, so that's not there yet. Here we go. 1, 2, 3, 4, 5, 6, 7. We got it. Mechanical advantage of 7. The last one wants 8. So I'm going to need 4 either on the top or the bottom. I suspect the bottom, but I'm going to make 4 and 4 just in case. I'm going to start way up here so that I have room to make a big, a medium little, and a little. And then on the bottom, I'm going to go right through that and make a big, a medium little, and a little. There we go. And I don't know which color I'm happiest with here. I'm gonna go to black. Let's see what that looks like. Yeah, that looks all right. So I want an even mechanical advantage. So I'm going to start at the top, but I'm going to start stringing around. 1, 2, 3. I'm going to stop there and just count. See where I'm at. 1, 2, 3, 4, 5, 6. Go around again. That's still going to be 6. Go to here, and it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Hey, I got it. There's 8. So I can leave it right there and say that my mechanical advantage is 8, and I'm done. But just to mentally note that if I had gone around that last one, it's still 8 because that last string here doesn't count because it's pulling down. It's still 1, 2, 3, 4, 5, 6, 7, and 8 for the mechanical advantage. The last thing before we move on is the distances here, which I've kind of butchered there. It's mechanical advantage equals dE over dL. And you're probably, what do you mean distances? We haven't talked about distances yet. Well, the dL would be the distance that the load moves. And dE would be the amount of rope you have to pull, or string or whatever, or chain or whatever is in your pulley system. So when you're calculating distances, that's what you're thinking of. How far does the load actually move up, and how much rope do you actually have to pull in your pulley system? I think that's pretty close to it. It is. And that's our last machine, other than compound machines where we try and put these things together. So that does cover all the machines that we're going to cover. Well, after this one, just watch the thing on compound machines. Take notes if you need to. Try the questions on your own with your own calculator. And then sometime early next week, Wednesday at the latest, I'm going to post a sort of take-home assessment, which will basically be the test that I normally give. And you guys can just do it instead of in class quietly. You can do it at home in the comfort of your own home. All right, that's going to be it for now.